Hi guys, welcome to this quest where we'll be considering different ways of applying ratios. Ratios are things we use or come in contact with every day. In fact, everything we touch has been influenced by ratio in one way or another. For example, the plan of the place where you are listening to this lesson was made using ratios. The clothes you are putting on probably consist of more than one material mixed together in a particular ratio. The food you eat is made according to a recipe that dictates that one ingredient will be mixed with another ingredient in a predetermined ratio. You could be asked to draw a model of something large, such as your house, as a school project, or you could do it out of your own curiosity. To do this well, you need to understand ratios. In this quest, we will be looking at different ways in which we can apply ratios every day. So, come along with me as we explore application of ratios. Mystical Nnamdi is an architect working on the construction of a shopping mall. If the distance between the parking lot and the jewelry store in the shopping mall is 700 meters on the ground, and the scale of the plan is 1 to 2,000, what will be the distance between the parking lot and the jewelry store on the plan for the shopping mall? Now make sure you go over the question again to be sure you understand it. Looking at this, one thing that stands out as an unknown is the word scale. What is the scale of a plan? The scale of a plan refers to the ratio between measurements on the plan and corresponding measurements on the ground. This means that the given scale, 1 to 2,000, is equivalent to saying 1 unit of measurement on the plan is equal to 2,000 units of measurement on the ground. We can write the definition of scale as the formula: scale is equal to measurement on the plan over measurement on the ground. That means 1 over 2,000 is equal to the distance on the plan over 700 meters. By cross multiplying, we have 700 meters times 1 equals distance on the plan times 2,000. Dividing both sides by 2,000, we have 700 meters over 2,000 equals distance on the plan. We can rewrite this as distance on the plan equals 700 meters over 2,000, which is equal to 0.35 meters. Since 1 meter is equal to 100 centimeters, 0.35 meters is equal to 0.35 times 100 centimeters, which will give us 35 centimeters. Therefore, the distance between the parking lot and the jewelry store on the plan for the mall is 35 centimeters. Hope you got that. Let's take another example. Tony and his friends are planning to travel for an excursion to a game reserve in Bauchi in northern Nigeria from Onitsha in southeastern Nigeria. They check the map and measure the distance from Onitsha to Bauchi and find out that it is 57 centimeters long. What is the scale of the map if the distance on the ground between Onitsha and Bauchi is actually 570 kilometers? This is quite straightforward, given what we have learned about scale. The scale of a map is equal to the measurement on the map divided by the measurement on the ground. That means the scale of the map Tony and his friends are checking is given by 57 centimeters over 570 kilometers. Notice that the distance on the map and the distance on the ground are in different units. Therefore, we need to convert them to the same unit since they must be in the same unit before we can get our scale. Recall that 1 kilometer is equal to 1,000 meters. Also recall that 1 meter is equal to 100 centimeters. That means 1 kilometer, which is equal to 1,000 meters, is equal to 1,000 times 100 centimeters. And that is equal to 100,000 centimeters. Therefore, the scale of the map is 57 centimeters over 570 times 100,000 centimeters, which is equal to 57 centimeters over 57 million centimeters. And that gives us 1 over 1 million. Therefore, the scale of the map is 1 to 1 million. Note that the scale of a map is given as a fraction, so you don't need to convert your answer to a decimal fraction. What does a scale of 1 to 1 million mean for Tony and his friends? It means that whatever the distance they measure on that map for any pair of points, they simply need to multiply it by 1 million to get the actual distance on the ground. So that's how you handle the scale of any map or plan. You can go and grab any maps or plans and try out what you have learned in this lesson. Join me in the next lesson as we look at another application of ratios. See you soon.